In this video, I'd like to provide one more example of how to identify the domain of a composition of functions. I covered this originally in the Unit 4 video, Part 1, Lesson 2. And if you jump back to that, or if you look at your notes there, the notes look something like this, where we have a four-step process in order to find the domain of a composition of functions. Now, the instructions were labeled this way. So we've got four steps, 1, 2, 3, and 4, and we essentially find the domain or the restriction on the inner function. We find the domain or the domain restriction on the outer function. And then in step 3, this is where some math gets involved. We need to find when the inner function equals the restriction of the outer, because we don't want to allow that to happen. We don't want the inner function to ever equal the restriction of the outer function. And after we've established that result, then our final answer is a combination of the result from step 3 and step 1. Now sometimes, as is the case with this particular example, let's see if I can find that. Here we are. Sometimes the simplified result is actually pretty straightforward. It's pretty easy to identify what the domain restriction is. And in this case, we're dealing with a fraction, a function that looks like a fraction. So the only trouble that we have with fractions that contain a variable is if the denominator of the fraction is ever equal to 0. So in this case, we don't ever want 1 minus 9x to equal 0. And so I'm just going to set up a mini equation here with an inequality. I don't want 1 minus 9x to equal 0. So I'll add 9x to both sides, and then I can divide by 9. And I'll end up with x not permitted to be 1/9. And we could investigate this. If I were to pick the number 1/9 and try to substitute it into this function, well, I'll get some answer in the numerator. 8 times 1/9 will give me a numerical value. But in the denominator, 1 minus 9 times 1/9, well, 9 times a ninth is 1, so 1 minus 1 equals 0, and we wouldn't be able to simplify that result. So that, again, further solidifies why 1/9 should be avoided. And if you trust your process, you'll recognize that 1/9 is the only number that's not permitted here. Now, if you didn't simplify your composed function like MathExcel walked you through the process to do, you might notice, since f of x is 8 over x minus 9 and g of x is equal to 1 over x, you might have composed f with g and simply gotten this, 8 over 1 over x minus 9. And finding the domain restriction here before it was simplified might be a little bit more challenging to do. So in that case, we would probably use the process. So step number 1 says to find the domain restriction of the inner function. Now the inner function is g. And so for our inner function, the only problem that we have here, the only value that would restrict this domain is 0. So we want to say that x is not allowed to be equal to 0. For step 2, we would investigate the restriction of the outer function. The outer function in this case is is f. So we're going to focus on the domain of the outer function. What's the restriction here? Well, in this case, again, we don't want the denominator to equal 0, and the number that makes that happen is 9. So on our outer function, our restriction is 9. So for step 3, when we set our inner function not equal to our restriction of the outer function, we're going to say that we don't ever want the inner function, 1 over x, to ever equal the restriction on the outer function. So 1 over x cannot equal the restriction that we identified here in step 2. So if I had an equation that I had to solve for x, there are a couple different ways we can go about this. One common approach is to multiply both sides by x. So now we know that 1 is not allowed to equal 9x. Now we can divide both sides by 9, and we see that 1/9 is not equal to x. So we've now established that the domain restriction, according to step 3, is 1/9. So x, let me write it this way, x is not allowed to equal 1/9, and that should be no surprise. That's essentially what we described back here by looking at our simplified form. But also, we can't forget that x is also not allowed to be equal to 0. So we actually have two answers here. We wouldn't have seen this restriction based on the simplified form of the expression. Now, why is 0 not permitted? Well, let's remember, this composition of functions, when simplified, looks like this. But in reality, the function was described or defined this way. What would happen if you tried plugging in the number 0 into this form of the expression? Well, in this case, if I tried substituting x with 0, we'll just make it stand out a little bit more here. If I substituted x with 0, well, I can't even get to the point to simplify this denominator because I now have a component that requests 1 to be divided by 0. Since I can't evaluate this with a real number result, I cannot evaluate f composed with g at 0. Back here, I could have gotten away with it. 9 times 0, of course, is 0, so 1 minus 0 is 1. So we can evaluate the denominator. That comes out to be 1. 8 times 0 is 0. 0 divided by 1 is 0. We can evaluate this simplified form, but we cannot evaluate the expression in its original, most accurate form. So if I were answering this question, I would note that the domain of f composed with g is all x values such that x is not equal to 1/9. That's an inequality that they're after. And x is not equal to 0. We would have two solutions, or two values that are excluded in this domain.